Hello students, in this video we are going to solve questions based on general term of geometric progression. So what is the general term for a geometric progression? The general term is Tn equals to A times r raised to n minus 1, where A is the first term and r is the common ratio for the given geometric progression. So let us see the first question. The given geometric progression is negative 27, 9, negative 3, 1, negative 1 upon 3 and so on. Here the first term is negative 27. The common ratio is given by the ratio of second term to the first term. So we divide the second term 9 by the first term negative 27, which gives 1 upon negative 3 or negative 1 upon 3. The nth term, the formula for nth term is A times r raised to n minus 1. Here the first term is negative 27 times the common ratio is negative 1 upon 3 raised to n minus 1. Now to simplify this, we need to convert the numbers with the same base. Negative 1 upon 3 can also be written as 1 upon negative 3. So to make the same base, we will use the common ratio as 1 upon negative 3. So negative 27 is negative 3 raised to the power 3 times 1 upon negative 3 raised to n minus 1. Any power of 1 any power of 1 is equal to 1. So there is no power in the numerator and the negative sign is taken to the denominator to make the same base. When the same bases are in division, their powers are subtracted. So negative 3 raised to 3 minus n minus 1. So on simplifying the powers, we get the general term Tn equals to negative 3 raised to 4 minus n. When we open the bracket with negative sign, the 1 will become positive. So 3 plus 1 is 4. So general term is negative 3 to the power 4 minus n. We also need to find the ninth term of this geometric progression. So the ninth term can be given using the formula T9 equals to A times r raised to 9 minus 1, or we have already simplified the general term for this geometric progression. So using this directly, T9 equals to negative 3 raised to 4 minus 9, which gives negative 3 raised to negative 5. To make the power positive, we take the reciprocal of the base 1 upon negative 3 raised to 5. So the ninth term of this geometric progression is negative 1 upon 243. Let us see the next question. Here, the geometric progression is 2, 2 root 2, 4, 4 root 2 and so on. So the first term given in this geometric progression is 2. The common ratio, which is the ratio of second term 2 root 2 upon the first term 2, gives root 2. The nth term of this geometric progression, the formula is Tn equals to A times r raised to n minus 1. So 2 times square root 2 raised to n minus 1. Now to simplify this, we need to convert the bases into the same number. So 2 can be written as square of square root. So square root 2 the whole square times square root 2 raised to n minus 1. And we know that when the same bases gets multiplied, their powers are added. So square root 2 raised to 2 plus n minus 1, which gives the general term n Tn equals to square root 2 raised to n plus 1. Now to find the 11th term, we can use the formula T11 equals to A times R raised to 11 minus 1, or we can use the simplest form of nth term for this geometric progression. So T11 equals to square root 2 raised to 11 plus 1, which is square root 2 raised to 12. Now square root can also be written as power half. So 2 raised to half whole raised to 12 gives 2 raised to 6. So the 11th term for this geometric progression is 64. Here is the next question. The geometric progression is 0.4, 0.8, 1.6 and so on. So here the first term is 0.4, which can be written as 4 upon 10, and on simplifying this 4 upon 10 is equal to 2 upon 5. The common ratio is 0.8 divided by 0.4. Multiplying both the numerator and denominator by 10, we get 8 upon 4, which is equal to 2. Now we know that the first term is 2 by 5 and the common ratio is 2. We can find the general term, nth term, using the formula Tn equals to A into R raised to n minus 1. So 2 upon 5 into 2 raised to n minus 1. So here in the numerator, 2 means 2 to the power 1 is getting multiplied by 2 raised to the power n minus 1. So what do we do when we have same base in multiplication? We add the powers. So 2 raised to 1 plus n minus 1 upon 5, which gives the general term Tn equals to 2 raised to n upon 5. Now to find the seventh term, we can use the formula T7 equals to A times R raised to 6, or we can use this simplified form for this question. So T7 equals to 2 raised to 7 upon 5 and 2 to the power 7. So when you multiply 2 7 times, you get 128 upon 5. So seventh term for this geometric progression is 1 upon 128 upon 5, which can also be written as 256 upon 10, that is 25.6. Since the geometric progression given was in decimal numbers, we have converted seventh term also in decimal form. Moving on to the next question of a different type. The question says, which term of the geometric progression square root 3, 3, 3 square root 3, 9 and so on is 729. So from the given geometric progression, we can identify the first term as square root 3 and the common ratio, that is the ratio between the second term 3 upon first term square root 3. On simplifying this, we get square root 3. So the first term and the common ratio in this question are same, that is square root 3. And the question is asking for the number of term, which term is 729. So let us assume nth term be 729. That means Tn equals to 729. So using the formula for general term a times r raised to n minus 1, in this case it is 729. So putting the values of a, square root 3 multiplied by square root 3 raised to n minus 1 equals to 729. So like previous question, when same bases are in multiplication, we add the powers. We have square root 3 raised to 1 and multiplied by square root 3 raised to n minus 1. So adding the powers, we get square root 3 raised to 1 plus n minus 1. Cancelling out plus 1 and minus 1, we get square root 3 raised to n equals to 729. Now square root 3 can also be written as 3 to the power half whole raised to n as it is, and 729 on doing prime factorization is 3 raised to power 6. So now using the formula for power raised to another power, which is multiplication of two powers, we get 3 raised to n upon 2 equals to 3 raised to 6. And when we know that when bases are same on left hand side and right hand side, in the given equation, it is possible only when their powers are equal. So we compare the powers, we get n upon 2 equals to 6. So that is n equals to 12. So this means that for this given geometric progression, 12th term is 729 is our answer. We move on to the next question, which says that find the geometric progression whose fifth term and eighth terms are 80 and 640 respectively. So we are given fifth term T5 equals to 80 and eighth term T8 equals to 640. So using the formula for general term of a geometric progression, what will be the fifth term formula? That will be a times r raised to 4, which is 80, and the formula for eighth term, that will be a times r raised to 7, which is 640. Now we have two equations to be solved simultaneously, and this can be solved by dividing the two equations. Since we have both the variables in product form, we divide equation 2 by equation 1. So on the left hand side we get a times r raised to 7 divided by a times r raised to 4, and on the right hand side we get 640 divided by 80. On simplifying this, we get r raised to 7 minus 4 because a will get cancelled out, and same base in division we will subtract the powers. So the left hand side will be r raised to 3, which is equal to, on reducing the right hand side to the simplest form, we get 8. So we have the equation where cube of a number is 8, and we know that cube of 2 is 8. So the value of r, common ratio for this geometric progression, is 2. Now substituting this value in equation 1 or equation 2 will give us the value of the first term. So putting in equation 1, we get a times 2 raised to 4 equals to 80, which is a times 16 equals to 80. So a times 16 equals to 80 means a equals to 80 divided by 16, which is 5. So we got the first term for this geometric progression 5, and the common ratio is 2. So now we can find out the geometric progression, which is 5 is the first term multiplied by 2. 5 into 2, that is 10, will be the second term. Again multiply by 2. 20 will be the third term. 40 fourth term. 80 fifth term, and so on. So the required geometric progression is 5, 10, 20, 40, 80, and so on. Now the next question, it says that for what values of x the numbers x plus 9, x minus 6, and 4 are in GP. So we know that when three numbers are in GP, their ratio of consecutive terms is constant. So we mark x plus 9 as T1, we mark x minus 6 as the second term T2, and 4 as third term T3. Then when these numbers are in GP, we can say that T2 upon T1 is equal to T3 upon T2, or we can write that T2 square equals to T1 times T3. So putting the given numbers in this equation, we get x minus 6 whole squared equals to x plus 9 times 4. On expanding the left hand side using the identity, we get x squared plus 36 minus 12x equals to, expanding the right hand side using distributive property, we get 4x plus 36. Now taking all the terms on left hand side, and for solving the quadratic equation, we get x squared plus 36 minus 12x. We take 4x on other side and 36 on other side. Both are positive. So on transposing, they become negative 4x, negative 36, and then we are left with equals to 0. Simplifying the like terms, we have x squared, then negative 12x minus 4x, that becomes negative 16x, and plus 36 minus 36 gets cancelled. So we have x squared minus 16x equals to 0. Taking out x common, we have x times x minus 16 equals to 0. So we get a quadratic equation solved, and it says that either x is equal to 0 or x minus 16 equals to 0 using zero product rule. So x minus 16 equals to 0 means x equals to 16. So we get two values of x. One is 0 and other is 16. So if we use x equals to 0, then our numbers x plus 9, x minus 6 and 4, they will become 9, negative 6 and 4. So these numbers are in GP. Now if we use x equals to 16, then the numbers x plus 9, x minus 6 and 4, that is 25, 10 and 4, they are also in GP. So the question for what values of x, the numbers x plus 9, x minus 6 and 4 are in GP, the answer is x equals to 0 and x equals to 16. Moving on to the next type of question. The question is, find sixth term from the end of the given geometric progression 16, 8, 4, 2 up to 1 upon 512. So here we have to find sixth term from the end, from the last. So if we consider this first four numbers as an example, 16, 8, 4 and 2, the common ratio is 8 upon 16, which is 1 upon 2, 4 upon 8, which is also 1 upon 2, 2 upon 4, which is also 1 upon 2. And now we consider this same sequence but in a reverse order, that is we take 2 as first number followed by 4, 8 and 16. Then the common ratio will be 4 upon 2, which is 2, or 8 upon 4, which is also 2, or 16 upon 8, which is 2. So we see that for a given GP, the common ratio will become reciprocal when we reverse that GP. So here our given GP is, for the given GP, first term is 16 and common ratio is 1 upon 2. And on reversing this GP, our first term will become the last term of the given GP, which is 1 upon 512. And the common ratio will become 2. So now to find the sixth term from the end, that is sixth term of reverse GP. So for this, sixth term T6 is equal to A times R raised to 5, which is 1 upon 512 times 2 raised to 5. We know that 512 is ninth power of 2. So 2 raised to 9 is 512. 1 upon 2 raised to 9 times 2 raised to 5 will give 1 upon 2 raised to 4. So the sixth term from the end of the given GP, which is also sixth term of the reversed GP, is 1 upon 16. The last question for this session. The question is, fourth term, sixth term and the last term of a GP is are 10, 40 and 640 respectively. If the common ratio is positive, find the first term A, common ratio r, and number of terms n. So here we are given with fourth term T4, that is 10. Then T6 equals to 40. And if we say that there are n terms in this geometric progression, then the last term, which is Tn, is given as 640. So using this information, we need to find the first term, common ratio, and number of terms. So T4 is a times r raised to 3, which is given as 10, and T6, which is a times r raised to 5, which is given as 40. So using these two equations with two variables a and r, we need to solve them simultaneously. So dividing equation 2 by equation 1, on the left hand side we get a times r raised to 5 upon a times r raised to 3, and on right hand side we get 40 upon 10. On simplifying this, we get r square equals to 4. So taking square root, r will be plus or minus 4. But here in the question, it is given that the common ratio is positive. So using this information, the value for the common ratio r will be 4. Now using this value of r in equation 1, we get, putting this value in equation 1, we get a times 4 raised to 3 equals to 10, which is a times 64 equals to 10. So the first term is 10 upon 64, or 5 upon 32. Now getting the value of first term and the common ratio, we can find the nth term. We can find the number of terms from the formula of nth term. So Tn, that is a times r raised to n minus 1, which is given as 640. We can write the first term as 5 upon 32 times 4 raised to n minus 1 equals to 640. So in transposing the numeric coefficient, we get 4 raised to n minus 1 equals to 640 times 32 upon 5. So in simplifying this, we get 128 times 32, which is equal to 4 raised to n minus 1. Now we know that the numbers 4, 128 and 32, all these numbers are powers of 2. So converting all these numbers in the same base 2, we get 2 raised to 2 whole raised to n minus 1 equals to 2 raised to 7 times 2 raised to 5. So in simplifying this, we get 2 raised to 2n minus 2 equals to 2 raised to 7 plus 5. Now we know that when the bases are same in the given equation, we can compare their powers. So 2n minus 2 equals to 12, or 2n equals to 14, or we get the number of terms as 7 for the given geometric progression. I hope you have learned how to use the general term formula for geometric progression in different types of sums. Thank you for learning.